So every redox reaction is going to have two parts: reduction and oxidation. The reduction, that reaction is what is endergonic, meaning it requires the energy. Oxidation is exergonic. So you can pair these together and have the energy that's released through oxidation be used to power the reduction. The way that I remember these is that the oxidation has an X and exergonic has an X. And then CER in endergonic is backwards of RED for reduction. That one's a little less certain. Not as comfortable with that one. Those oxidation steps release the energy, and those reduction steps use the energy. So essentially, this energy that's being released gets used in the second part of these reactions. Our big question, though, that we have is, how does this energy get transferred? So the energy is transferred by electrons, which often travel with a hydrogen ion. So, if our reduction reactions are endergonic, whatever gets reduced accepts those electrons, because those electrons come with a lot of energy, and we need energy to power these reactions. The oxidation steps, those are exergonic, meaning that they are the ones that donate electrons. So you can see how we get energetic coupling. So we are going to make a very, very simplified sketch of what's going on here. I'm going to label one side thing 1, another side thing 2. And thing 1, I'm going to say gets oxidized. Then my thing 2, I'm going to say gets reduced. So what that means is that thing 2 accepts an electron that's donated by thing 1. So I'm going to draw my electron being transferred from thing 1 to thing 2. And here's where scientists made things just a little bit more complicated. Because thing 1 is responsible for the reduction of thing 2, scientists decided that we needed to call this the reducing agent. And because thing 2 is responsible for thing 1 getting oxidized by taking those electrons, scientists decided to call thing 2 the oxidizing agent. Unfortunately, those terms make it very confusing to keep redox reactions straight. The important thing, though, is when something is oxidized, it donates electrons. And when something is reduced, it accepts those electrons that have been donated.